Next, we're going to talk about the network media itself. Let's start out by talking about copper cabling. Networks use copper cabling media because it's inexpensive, it's easy to install, and it has low resistance to electrical current. However, copper media is limited by distance and its signal interference. With data is transmitted on copper cables as electrical pulses, and a detector on the network interface of the destination device must receive the signal that can be successfully decoded. If the signal is too weak, it may not be able to decode that signal when it comes in. And also, the longer the distance the signal has to travel, the more it deteriorates, and a phenomenon referred to as signal attenuation. So for this reason, all copper media must follow strict distance limitations as specified by the guiding standards. Again, we're talking our standards again. The timing and voltage values of electrical pulses are also susceptible to interference from two sources. You have electromagnetic interference, or EMI, or radio frequency interference. The EMI and the RFI signals can distort and corrupt the media signals that are being carried by copper media. Potential sources of this are radio waves and electromagnetic devices such as the fluorescent lights or electric motors as shown in the figure to your right. Typically, like here on campus in a classroom, we're not going to run our copper cable across the ceiling because we do have fluorescent lights, and that will affect our signal strength. I'm going to run the example here in the figure for you to see how the electromagnetic interference and the radio frequency interference can have that interference occur. So that once the signal gets to the computer, you have your pure signal, then you have your interference, and the two of those kind of combine with each other, and then the computer reads it as garbly-goop, basically because the signal isn't in the patterns that it's looking for. You can also have crosstalk, and that is the disturbance caused by the electric or magnetic fields of a signal on a wire to the signal in and adjacent to the wire in the signal of an adjacent wire. Telephone circuits, crosstalk can result in hearing part of another voice conversation from an adjacent circuit. Specifically, when electrical currents flow through a wire, it creates a small circular magnetic field around the wire which can be picked up by an adjacent wire. I know this happens in my home sometimes when we've had a bad rain. If our neighbor and I are on the line at the same time, we can hear each other's conversation, or at least portions of it, and we know that's occurring. To counter the negative effects of EMI and RFI, some types of copper cables are wrapped in a metallic shielding and require proper grounding of those connections. And to counter the negative effects of crosstalk, some types of copper cables have opposing circuit wire pairs twisted together, which effectively cancel the crosstalk. The susceptibility of copper cables to electric noise can also be limited by selecting the type of cable and the category most suited to your given networking environment, and designing cable infrastructure to avoid known and potential sources of interference in the building structure. Also, using cable techniques that include the proper handling and termination of the cables. There are three main types of copper media used in networking. We have our unshielded twisted pair. That is this one here. You have your shielded twisted pair. This one. Here's the shield. You'll notice this one does not have it on there. And then you have your coax cable. These cables are used to interconnect nodes on a LAN and infrastructure devices such as your switches, your routers, and your wireless access points. Each type of the connections and the accompanying devices have cabling requirements stipulated by the physical layer standards. Keep in mind, you always have standards. Different physical layer standards specify the use of different connectors. So you would not use the same connector end on this device that you would use on this device. The standards specify the mechanical dimensions of the connectors and the acceptable electrical properties of each type of connector. An example is the Rj45 connector is widely used in LANs with one type of media and in some WANs with another type of media. The Rj45 connector looks very similar to your connector where you are hardwired with your phone into a wall jack. Your unshielded twisted pair or UTP cabling is the most common networking media. UTP cabling is terminated with the Rj45 connectors, and it's used for interconnecting network hosts with intermediate networking devices such as switches and routers. When we're using LANs, the UTP cable consists of 4 pairs of color-coded wires that have been twisted together and then encased in a flexible plastic sheath which protects them from minor physical damage. The twisting of the wires helps protect against signal interference from other wires. It also helps with crosstalk. As you see in the figure to your right, the color codes identify the individual pairs and wires in the pairs and aid in cable termination. So here we have our outer jacket, the twisted pairs, and then they're color coded. Typically they're orange, orange-white, we have green, green-white, blue-white, blue, and brown-white. I know it looks black on here, but they're brown. Then we have our shielded twisted pair, and it provides better noise protection than the untwisted pair. However, compared to the UTP, the STP cable is significantly more expensive. It's more difficult to install, and both of them use the Rj45 connectors. Your shielded twisted pair combines the techniques of shielding to counter the EMI and the RFI, and wire twisting to counteract the crosstalk that can occur. To gain the full benefit of the shielding, the shielded twisted pair cables are terminated with special shielded twisted pair data connectors. And if the cable is improperly grounded, the shield may act like an antenna and pick up unwanted signals. So you have to be very careful when you're creating your connector that you're doing it correctly. So here we have our jacket. We've got a braided or foil shield. It can be either one. Here we have foil shields, and then we have our twisted pairs. Next we have our coax cables or coaxial cables. It gets its name from the fact that there are 2 conductors that share the same axis. As shown here, we have our outer jacket, you have your braided copper shielding, you have your plastic insulation, and then you have your copper conductor. The copper conductor is used to transmit the electronic signals, and the copper conductor is surrounded by the flexible plastic insulation. You have different types of connectors. This is a B and C. You have your N-type and your F-type connectors. It all depends on what you're going to use them for as to how the cables are connected. All 3 types of copper media are susceptible to fire and electrical hazards. Fire hazards exist since cable insulations and sheaths may be flammable or produce toxic fumes when heated or burned. Building authorities or organizations may stipulate related safety standards for cabling and hardware insulation. Some of the electrical hazards are a potential problem since copper wires could conduct electricity if in undesirable ways. This could subject personnel and equipment to a range of electrical hazards. So you do have to take caution when you're installing cables that you've installed them correctly. and you follow the standards. Again, here is an activity that you can do. We have UTP cabling, and again, that is our unshielded twisted pair. The unshielded twisted pair does not use shielding to counter the effects of EMI and RFI. Instead, the cable designers have discovered that they can limit the negative effects of crosstalk, one by cancellation, and that's where the designers now pair wires in a circuit, and when two wires in an electrical circuit are placed close together, their magnetic fields are the exact opposite of each other, so they cancel it out. Also, varying the number of twists per wire. To further enhance the cancellation effect of the paired circuit wires, designers vary the number of twists of each wired pair in the cable. With the unshielded twisted pair, must follow precise specifications governing how many twists or braids are permitted per meter of cable. You'll notice in the figure to your right that the orange-white pairs are twisted less than the blue-white pairs, and each color is twisted in a different number of times. And you can see that if you look closely at these. You'll notice that the brown-white-brown is even looser or has less twist than the orange-white. The UTP cable relies solely on the cancellation effect produced by twisting the wires, the pairs together. Also with UTP cabling, it conforms to the standards established jointly by the TIA and EIA. Specifically, 568A stipulates the commercial cabling standards for LAN installations and is the standard for most commonly used LAN cabling environments. Some of the elements that are defined are the cable type, the cable length, what type connector we're going to use, and the method of testing the cable. The electrical characteristics of copper cabling are defined by the IEEE, and it rates UTP cabling according to the performance. Cables are placed into categories according to their ability to carry higher bandwidth rates. For example, a Cat 5 or Category 5 cable is used commonly in 100 base TX fast Ethernet installations. Other categories include the Enhanced Category 5 or Cat 5e, and then you have the new Cat 6 or Cat 6a. Cables in the higher categories are designed and constructed to support higher data rates as new gigabit speed Ethernet techniques are being developed and adopted. Cat 5e is now the minimally acceptable cable type, with Cat 6 being the recommended type for new building installations. And this changes as technology increases. The UTP cable is usually terminated with an ISO 8877 specified Rj45 connector, and this connector is used for a range of physical layer specifications, one of which is Ethernet. This video is going to display a UTP cable terminated with the Rj45 connector, and then I'll show you figure 2, which is the Rj45 connector in the male component, and it's crimped at the end of the cable, and the socket of the female component in a network device. Each time copper cabling is terminated, there is the possibility of signal loss. You may have crimped a cable too hard, you may have caused one of the wires to break. So let's watch this one right quick. Here's the Rj45 untwisted pair plugs. Here's this one, here's both ends of that one. And these are different types of sockets that they can be plugged into. This is a bad connector. Do you see how the wires are from the shield here or from the plastic cabling? and the connector itself, you can see the wires. This is a poorly constructed connector. This one is good. There's different situations may require that the UTP cables be wired according to different wiring standards. You have the T568A and the T568B. The 568A is green, white, green, orange, white, blue, blue, white, orange, brown, white, brown. If you're using the 568B, you have orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. So there are a little bit difference. Your Ethernet straight through have both ends as either the 568A or the 568B. And these connect a network host to a network device, such as your switch or your hub. You can have a crossover cable where one is the 568A and the other is the 568B. This is going to connect two network hosts, or it will connect two network intermediary devices such as switch to switch or router to router. Then you have your rollover cable. These are Cisco proprietary cables, and it connects a workstation serial port to a router console port using an adapter. After installation, a UTP cable tester should be used to test the cables to make sure that they're working. If you create your own cables and you plug them in and things still are not talking, you need to test this to make sure that you have properly made your connections. The tester is going to look at the wire map, the cable length, the signal loss due to attenuation, and see if there's any crosstalk going on. This activity here, you can create and see if you can remember how cables are connected. You just come in here and drag and drop your cables, how you think they should be done. Just drag them like this. Since you can't make your own cables, this is one way to see if you're getting the pin out. This is asking for the 568B. You can check it and see which ones you got correct. If you didn't get them right, you can switch them out. We'll say, okay, I wonder what I got wrong. Move them around, see if that corrected it. No, you're still not right. So you can just play around with it and see how things need to be set up. Okay, so make sure you work on this to get your understanding of it. This is a lab that you can go through. You will not be able to actually do it live. I don't expect you to have to go out and buy the equipment in order to practice creating your own cables. Next we have fiber optic cabling, and the optical fiber cable has become very popular for interconnecting interface network devices. Here locally in Cleveland County, there's a company now who is running fiber optic throughout the county. And their speeds are phenomenal on the fiber optic cable. It's now being used in 4 types of industry. We have enterprise network. The fiber is used as the backbone cabling applications and interconnecting infrastructure devices. That is because the cable is able to transmit your data quickly, cleanly across the networks. You have the FTTH and access networks, or the fiber to the home, is used to provide always-on broadband services to homes and small businesses. It supports affordable high-speed internet access as well as telecommuting, telemachine, telemedicine, and video on demand. It's quick and it's clean. You have long-haul networks. These are service providers using long-haul terrestrial, can I hardly say that word, optical fiber networks to connect countries and cities. You can run fiber in much longer distances than you can the other types of media. And then you have submarine networks. Those are special fiber optics are used to provide reliable high-speed, high-capacity solutions capable of or surviving a harsh undersea environment, such as the transoceanic distances. Although the fiber optic is very thin, it's composed of two kinds of glass and a protective outer shield. You have your core that consists of pure glass and is the part of the fiber where light is carried. You have your cladding, that's the glass that surrounds the core and acts as a mirror. The light pulses propagate down the core while the cladding reflects the light pulses. Then this keeps the light pulses contained in the fiber core in a phenomenon known as total internal reflection. Then you have your jacket, and it's typically a PVC jacket that provides the core and cladding, and it protects it. It may also include strengthening materials and a buffer or a coating whose purpose is to protect the glass from scratches and moisture. Light pulses representing the transmitted data as bits on the media are generated by either lasers or light emitting diodes, the LEDs. Electronic semiconductor devices called photodiodes detect the light pulses and convert them to voltage that can be reconstructed into data frames. Our fiber optic cables can be broadly classified in two types. You have your single mode fiber and you have your multi-mode fibers. The single mode fiber consists of a very small core and uses expensive laser technology to send a single ray of light. It's popular in the long distance situations spanning hundreds of kilometers, such as required in long-haul telephony and cable TV applications. Your multi-mode fiber consists of a larger core and uses LED to send the light pulses. Specifically, light from an LED enters the multi-mode fiber at different angles, and popular lands because they can be powered by low-cost LEDs, and it provides bandwidths up to 10 gigabits over link lists of up to 550 meters. Figure 1 and 2 highlight the characteristics of the multi-mode and single-mode fiber. One of the highlighted differences between the two is the amount of dispersion, and that refers to the spreading out of the light pulse over time. The more dispersion there is, the greater the loss of signal. So here we have a single mode, and this is the multi-mode. We have different connectors for our fiber optics. You have your straight tip, that's older. You have your subscriber connector and your lucent connector. Then we have our multiplex multi-mode lucent connector. And this is what your patch cables may look like. There are ways to test your fiber optics, and some of the problems that you can have with termination and splicing, or you have misalignment, and that's where the fiber optic media are not precisely aligned to one another when joined, and this can cause those light pulses not to be transmitted properly. You have an end gap, and that's the media does not completely touch at the splice or connection. And then you have end finish, and that's where the media ends are not well polished or dirt is present at the termination point. There's many advantages to using fiber optic compared to copper cables. Some of the optical media implementation issues include more expensive than copper media over the same distance, but you have a higher capacity. You have different skills and equipment is required to terminate and splice the cable infrastructure. You need to be skilled and trained in order to splice and terminate fiber. And it's more careful handling than copper media itself. Again, we have another activity. Now we have our wireless media. The figure to the right highlights various related symbols when you have wireless being addressed. Your wireless media carries electromagnetic signals that represent the binary digits of the data communications using radio and microwave frequencies. I'm sure you've seen these signals in different restaurants, industries that you've gone into, and you may also see them on your smartphones and other devices. Wireless does have some areas of concern, including the coverage area. The wireless data communication technologies work well in open environments. However, certain construction materials used in buildings and structures may limit your coverage. Also, the terrain. You have interference. Is susceptible and can be disrupted by such common devices as your home cordless phone, some types of fluorescent lights, microwave ovens, other wireless communications, and then you have your security concerns. How secure is that wireless connection? Devices and users who are not authorized to access to the network can gain access to the transmissions, so they can grab your information. So you have to be careful there. The IEEE and telecommunication industry standards for wireless data communications cover both the data link and the physical layers. You have your standard IEEE 802.11. Those are for your wireless LANs, and that's technology, and it's commonly referred to as Wi-Fi. You have your standard IEEE 802.15 for wireless personal area networks, and those are commonly known as Bluetooth. And then you have IEEE 802.16, and it's commonly known as the Worldwide Interoperability for Microwave Access, or WiMAX. The figure to your right shows you the different logos that you would see and explains the distances and the speeds that they all represent. It's going to talk about your data to radio signal encoding, your frequency and power of transmission, your signal reception and decoding requirements, and your antenna design and constructions are all laid out in those standards. Common wireless data implementation is enabling devices to wirelessly connect via a LAN. In general, a wireless LAN requires the following network devices. You need a wireless access point. What that does is it concentrates the wireless signal from users and connects usually through a copper cable to the existing copper-based network infrastructure, such as your Ethernet. From your home and small business, wireless routers are usually integrated in the functions of the router or the switch that you use in your home. You also have a wireless Nic Adapter, and that provides the wireless communication capability to each of your network devices or your network hosts. As the technology has developed, a number of wireless LAN Ethernet-based standards have emerged. So you need to pay attention when you're making your purchases that you're all using the same standard. The various 802.11 standards have evolved over the years. Here's an example and a good chart for you to remember. And they're not always backward compatible. So pay attention when you do purchase that wireless router or wireless access point that it fits within the means and the configuration of your current devices. You'll do this packet tracer and make sure you submit both the PKA and the Word doc that goes with it. Again, you're going to have to just read and to understand this information on the lab itself, because I'm not going to have you submit that to me.